Hey everyone, welcome back to the Amazon EKS series. In the previous video, we discussed about the cluster autoscaler and how it helps with the node scaling in Kubernetes. But in real production environment, cluster autoscaler comes with few limitations, especially when it comes to the speed, flexibility, and cost optimization. And that's where the Karpenter comes in. Karpenter is a next generation Kubernetes node autoscaler built by AWS, designed to provision the right node at the right time and for the right workloads without relying on the traditional node groups and autoscaling group as we were using in cluster autoscaler. So in this session, we'll first look at the problem with cluster autoscaler and then understand how Carpenter solves these problems. And also, Carpenter is now current and open source under CNCF. Then we'll dive deep into the Carpenter's internal working, including the core components like NodePool YAML and EC2NodeClass, understanding the end-to-end scaling flow. Finally, we'll wrap this session by performing a hands-on demo where we'll deploy a Carpenter on AWS EKS and see how dynamically provisions the nodes in a real time. So if you want faster scaling, better cost optimization, and simpler node management in Kubernetes, this video is for you. And all the source code, documentation, readme code will be present in this GitHub repository. Link will be provided in the description, so do check this out. And this is the official documentation of Carpenter, so we'll use this documentation while performing the demos and all. So you can also check this out. Go to the get started section, and here getting started concepts, you can find the all documentation. This is well written documentations, so you can refer this also. And if you guys are new to my channel, make sure to like and subscribe because it highly motivates me to make more such content. So now without getting late, let's get started. So agenda of the today's video. So we'll start first by addressing the problems of cluster autoscaler. Then we'll look into the Carpenter, how it solves those problems. Then we'll look into the benefits of Carpenter. Then we'll deep dive into the Carpenter, understanding its core components like NodePool YAML and EC2 Node class. Then we'll look into end-to-end scaling flow, and then we'll perform an end-to-end hands-on on this Carpenter on EKS cluster. So let's first have a short recap of what Cluster Autoscaler was doing. So whenever the pod was in pending and unschedulable state, so again, if you are not understanding this pending and unschedulable state and all, so I highly recommend you to watch my previous video first, in which I have explained completely of how the cluster a pod is coming into the existence from complete flow, pending state, unschedulable state, how pod is provisioned, everything I've explained in this. So I highly recommend you to watch that first video. Then you will have a better understanding of what we are addressing today in this video. So where we be? So yeah, pod was in pending state. So once the pod was in pending state, the cluster autoscaler was getting triggered, and then the cluster autoscaler was calling the autoscaling group of that node group, and then the EC2 instance was added in that node group, and the pod was coming into the running state. So this was the flow, right? And all was this happening into the predefined instance type. So we were defining some instance type in the configurations, and it was picking only those instance types only, no matter how your workload is scaling or scaling down, and it was bound to that specific auto scaling group only. This is what all happening in cluster autoscaler. And now what are those problems? The problems with the cluster autoscalers are like the static instance type means it was scaling only the instance type that we were mentioning, irrespective of what type of workload you want, what type of workload you are running, whether they want a general purpose or a GPU. It doesn't matter. It was only using only that specified instance type, and that is what the main problem is. And the slow scaling. You can see in this, there are many steps to perform. First, it was triggering cluster autoscaler, then it was calling cluster autoscaling group, and it was adding the nodes in that node group, and then the pod was coming into the running state. So it was taking a lot of time. It was taking nearly 2 to 3 minutes to provision that node. So in production, we don't want that time to take to provision one node. So slow scaling was one of the problem. So next is over provisioning. So it was often launching the larger and unnecessary nodes. Means In that configuration, we were mentioning instances like T3 medium, T3 large, and any instances that you want. What can happen is, if there is just only one single pod which is in pending state, and then to run that one single pod, it may run that big instance. So it is over provisioning, even if we have just one single pod which is in pending state. So such things can happen with the cluster autoscaler. And next is poor bin packing, means inefficient resource utilization. Even to even if to run that one single pod, it is running that complete EC2 instance, and all the resources are being underutilized, right? Such things can happen with cluster autoscaler. And next is limited cost optimization. There is no intelligent there is no intelligent decision making between spot versus on demand instance. It was choosing only the instance type that we were mentioning in that configurations. Even if the workload needs the small instance type, it was provisioning the larger instance type. So it was completely wasting the cost. So these are some of the problems that cluster autoscaler has, and at scale and in cost optimization, these problems are very much sensitive for production environment. So these are the some problems of cluster autoscaler, and these problems become more visible when we are running a more highly scalable infrastructure, and it can eventually cost you for unwanted workloads because of over provisioning and poor bin packing and limited cost optimizations. So these are some of the problems that Carpenter can address you, and now we'll look into that. So how Carpenter solves these problems? So one thing is, Carpenter has dynamic instance selections. Means in cluster autoscaler, you were mentioning the specific instance type to choose, but Carpenter chooses it dynamically, and it has faster scaling without relying on traditional services like autoscaling group. It has smart bin packing. It has automatic cost optimizations. Means the carpenter chooses the instance type that contributes less to your cost, and also the carpenter is too fast. Cluster autoscaler was taking 2 to 3 minutes to launch the new nodes, but carpenter does it in seconds. So now let's look into the some benefits of using carpenter. So as I told, carpenter is fast. Unlike your cluster autoscaler, carpenter takes just seconds to launch the new nodes for your cluster, and it has better cost optimizations. Like cluster autoscaler was provisioning unwanted and unnecessary nodes, but Carpenter chooses the best EC2 instance that contributes less to your cost and also best fits for your workload. Improved bin packing, and then intelligent instance selection across the families and size. Like families here means EC2 instance belongs to different families like M, C, R, and there are many families and different size of those families. So this is the high level view of how the nodes are scaled when we are using Carpenter. So whenever the pod was coming in pending state, it will trigger a cluster autoscaler, and sorry, it will trigger Carpenter, and Carpenter will launch the new EC2 instance, and that EC2 instance will join our cluster. So this is the flow of our carpenter. So unlike and again, how this carpenter launches the EC2 instance and all those internal working core components, we'll look into it slightly. So there is no cluster autoscaler triggered, there is no autoscaling group triggered, no node group, no EC2 instance is added in is a node group. So it was taking too many times. It was taking 2 to 3 minutes when we were using cluster autoscaler, but when we are using Carpenter, it will take in time in seconds. So now let's understand the internal working of the Carpenter by understanding the core components like NodePool YAML and EC2 Node class. So firstly, what is NodePool YAML? So NodePool YAML defines the rules of how to create a EC2 instance. It is that simple. So it is just simply a YAML file that has a set of instructions which defines of how a EC2 instance should be created. So while creating an EC2 instance, those rules needs to be followed. So that is NodePool YAML. So now what are those rules? We'll look into that now. So this is that YAML file of a NodePool. So I'll explain this YAML file, all the components over here step by step. So firstly, we have a API version and kind. So what this tell is, so this tells Kubernetes what resources to create. So kind NodePool means a resource of NodePool will be created. So now next is metadata. So metadata, here we define the name of this YAML file. So here we have given name as default. So default will be the name of this YAML file. And also we can create multiple node pool files. And then you may have this question, if we have multiple node pool YAML files, then which file do the Karpenter refer? So Karpenter will evaluate all the node pool files when scheduling. So next is the heart of this node pool, which is inside the spec template spec in this requirements. So these are all the requirements that an EC2 instance should be follow. EC2 instance should follow. So what it defines is, so every node created from this node pool should follow these all requirements. Now what these requirements and all. So let's first understand here. So key kubernetes.io slash architecture and operator as in and values AMD64 means EC2 instance should be created and that architecture that instance is using should be of AMD 64 only, not, or you can add any other architecture in this list. And operator in means use only the values from this. And also you have another operator not in. Not in means exclude these values and use any other value. And next is OS. Operator as in, value as Linux. You can pass any other value. So next is capacity type. Operator in, values as on demand. You can pass other values like spot and reserved. And next is instance category. Operator in, value as CMR. You can look into this image for more understanding. And next is instance generation. Operator as GT means greater than, value as 2. So let's go into this documentation and you can find many things over here. Come to the concept, node pools, scroll down here, and here you can find many other things. So our category we looked, so instance family, operator as in M5, M5D, C5, many things are here. And then instance CPU also 8, 4, 1632, and then instance hypervisor, Nitro, and then instance generation that we looked, and then also zones, at which zone you want to create your nodes, and architecture, and these are capacity type. So these are other some examples of requirements that we can also add. So okay, next is node class ref. So we haven't looked into the EC2 node class yet, but what this block is signifying is it's just telling it which EC2 node class to refer. So we haven't looked at this EC2 node class. We'll look into it in just slight time. And then next is expire after. So here we have given value as 720 hours, which is 30 days. So what it does is, in simple terms, it removes all the existing nodes and adds the new nodes. After that, 720 hours, even if the nodes are healthy. Next is limits. So limits is what it tells is, for example, if your node pool is scaling 5 EC2 instance, then the sum of CPU of all those 5 instance should be less than 1000. If the CPU sum of all the 5 CPUs crosses the 1000, Carpenter will stop scaling for this specific node pool only. Next is disruption. Cost optimization behavior controls how Carpenter deletes the nodes. So in this consolidation policy, we have wrote when empty or underutilized. Such we have three different values like when empty, when underutilized, when empty or underutilized. So let's address all of them. First is when empty. Means Carpenter will delete only the completely empty nodes. Means when the scale down has happened, if the node don't have any pods running in them, if that node is completely empty, then only Carpenter will remove that node or delete that EC2 instance. So next is when underutilized. Means Carpenter first finds the nodes with low utilization, evacuates the pods to the other EC2 instance, or if there is no EC2 instance, it launches the new EC2 instance with lower resources and then deletes that extra node. And next is when empty or underutilized. So this is the combination of both when underutilized and when empty. So it deletes the nodes. When they are empty and also when they are underutilized. So it is the combination of both of them. So in high level, if I want to mention what this node pool is doing is, so this node pool will allow Carpenter to create Linux AMD 64 on-demand EC2 instance of CMR families with generation greater than 2, and summation of CPUs of all the instances should be 1000 or less than that. And next is aggressively consolidate nodes. Here aggressively means this when empty or underutilized. When we are using when empty or underutilized, our Carpenter will behave aggressively to delete the nodes. And you can use other things like when empty or when underutilized. They both are less aggressive as compared to this. And next is recycles the nodes every 30 days. This expire after every 30 days your nodes get recycled. So next is we'll learn about EC2 node class. So till now we looked into the node pool YAML. So it was all about rule and intent of how, not how, the EC2 instance that created is following. And next is EC2 node class. It defines exactly how a EC2 instance should be created. Means a EC2 instance should have an AMI ID, and that EC2 instance being created, at which subnet that EC2 instance should be created. So we need that also information. We need a security group for that EC2 instance. We need an IAM role for that EC2 instance. We need also add tags to that EC2 instance. So these all informations can be given in this EC2 node class. And next we'll look into the this YAML file. Again, I would took this YAML file from this documentation only. You can find that in this documentation. And let's address this here. So firstly we have kind and DPI version. Next is metadata name as default for this file. Next is spec role. So this is important. Every EC2 instance launched will have this Carpenter node role, and again we need to create this role. I will explain about this role more slightly. We need to create IAM role, IAM policy, Carpenter controller role. So we need to address these all things. We'll look into it just slightly. And next is AMI selected terms. Which AMI needs to be selected? So alias as AL2023 at the rate a version. So here is, so this alias are mapping to some specific set of AMIs. So this node class will choose the AMI from that set only. And next is subnet selected terms. Means this EC2 instance launching, this EC2 instance that is getting launched by this EC2 node class, at which subnet this EC2 instance should be launched. The EC2 subnet, only the subnets that has this tag carpenter.sh slash discovery cluster name. So we already need to add this tag. And next is security group selectors, which means we first need to create a security group and should add a tag to that security group. Then EC2 instance will come up and will take that security group only which has this tags. So these are very much important: subnet selector and security group selector. If these two are missing, your nodes will completely fail. Your carpenter will not be able to add the EC2 instance, or that EC2 instance will not be able to join your cluster. Now let's discuss what IAM role policies we need to create for our carpenter. Because if you mess something around this, our carpenter will not able to create IAM rules, and that EC2 instance will not be able to join our EKS. So we need to be very careful around this. So now what I will do is, now I will explain you what role we need to create and what is the purpose of that role. So first we need to create this carpenter controller role. So this carpenter controller role will help us to talk to AWS to create or delete EC2 instance. So let me explain that. What do I mean by that? So that carpenter controller is running like a pod inside our EKS cluster. And now that pod will be talking to our AWS to create or delete the EC2 instance. Now this pod needs that permissions to talk to AWS, right? So for that, what we create is IRSA, a service account, and we attach that service account to this pod. And now that service account needs some rule and policies, right? So that is what this carpenter controller rule and controller IAM policy is doing here. That rule will be attached to this service account, and now that service account is attached to this pod. Now this pod can easily talk to this AWS to create or delete the EC2 instances. So let me explain that to you in code so that it gets completely clear. So see here, firstly we are creating that carpenter controller role, and we are attaching some policies to that. Assume role policy, a trust relationship. See here, assume role with web identity. We are adding OIDC provider URL. Also, we are adding subject as service account in the namespace Karpenter, and the name of the service account is also Karpenter. And in principles, we are adding EKS OIDC ARN. And again, I have got this policies from the documentation only. So you can come to this documentation here, migrating from Cluster Autoscaler, and scroll down here, and here you can find that. See here, this is that role. See here, service account in the namespace, whatever namespace you can give here, and carpenter. And federated principal we are giving as YDC, and subject audience we are giving as YDC endpoint here. And what policy is that? This is that policy we are creating. This is that policy we are creating. This is a bunch of policies we are adding here. I've also added these policies in this code also. You can find that here it is. Add policies. Yeah, here it is. These are bunch of policies that we need to add. You can refer the documentation also. Next is this node IAM role and node IAM policy. So our carpenter will scale the EC2 instances. So that EC2 instance which is scaled by our carpenter need to function as our worker nodes of our Kubernetes. So for that we need to create this rule and policies and attach these rules and policies to that EC2 instances. So let me show you that in code here. So here is the worker carpenter node role. So this is the trust relationship of that. STS assume role EC2 Amazon AWS.com, and these are the policies that we are adding: worker node policy, CNI policy, ECR read only policy, and SSM instance core. And next we need to create this instance profile. Now what is this instance profile? So our EC2 instance which are launched by our carpenter, those EC2 instance need to assume this role, right? Now how they will assume? With this instance profile. So if you have this instance profile, they can easily assume this rule and policies. So here see, we have created this instance profile. If we have this instance profile, they can easily assume that. And next I need to address one more thing, is that we need to create an EKS access entry of this node IAM role. If we don't create this, what happens is our carpenter will launch the EC2 instance, but those EC2 instances will not be able to join our EKS cluster, and eventually the pods will not be able to schedule in that node. I will show you while performing the demo that how we need to add this and what errors we get if we don't add this. So now let's apply all this Terraform code. and make sure to follow this code because I have updated something over here like IAMs we have added here, IAM role policies, and also in EKS we have added this taint. So by this taint, all only in this node group system workloads will be executed, not our application workload. By this taint, under this a label I have added node role as system. So make sure you to update all the necessary things over here, and then we'll simply apply this. So Terraform init. Okay, next Terraform plan hyphen var file. So this will plan our complete infrastructure. So yes, it has planned and it is saying that 42 to add. So let's simply apply this now. Terraform apply. So now this will take nearly 15 minutes to apply our incomplete infrastructure. Type yes over here. So till then I'll pause this video. So yes, now our complete infra is up and running. Now let's log in inside this Bastion host now. So firstly we'll configure the user AWS. So yes, now the our terminal has been configured. Now I will use this update kubectl command. Name of our this is the name of our EKS cluster, and hit enter. A .kubeconfig file will be created. So yes, a .kubeconfig file is created now. So let's test that kubectl get pods. Kubectl get NS. Kubectl get nodes. So currently we have just one single node. So now let's install the all the required things for to deploy our Karpenter. So firstly, we'll install the Helm. So take this command, paste that. So Helm, I've already installed that. So I have that Helm, and then just a second. And next is we'll install these CRDs. But before that, we need to create a namespace. So let's create a Karpenter namespace. kubectl create ns. So I have already created that namespace. So let me show you that kubectl get ns. So we have that Karpenter namespace created. Let's create all the CRDs. And here we are using this Karpenter version. So make sure to export this here. How to export that? Export Karpenter version, and current version is 1.8.6. You can also view that over here in this getting started Karpenter. Here they have mentioned that. Just hit enter and you can view also that echo dollar, so you can get that. So now just take this, hit enter. So yes, all the CRDs are now created, and we got this error because Carpenter ML is not yet created. So let's first create that and then apply that. So how to create Carpenter YAML, again in this documentation I have given that here. So by this a template file will be created. Just make sure to change your cluster name and the controller role here. So let's change those things and add. I'll take this here and I'll come to my code section here because I want to update that. So here I will update first name EKS dev EKS demo. So this is the name of our cluster, and next IAM role. So let's take the IAM role, come to IAM, take this ARN. So see, and the rest of the things like here resource, memory limits, these are the that pod will take this much of resources, one CPU, 1 GI of memory, and these are the limits for that. So next is simply take this command and paste it here and hit enter. So a template file is created now. Ls say Carpenter template file is created. So next apply kubectl apply -f carpenter.yaml. All the required things are installed now. You can check that kubectl get all in the namespace Carpenter. So see, pending. So we had a replica of two, so the two pods are running. So let's delete one pod. So kubectl get pods namespace carpenter.yaml carpenter kubectl delete pod slash this one in the namespace carpenter. Okay. So again it is launching that pod because we have set the replica is 2, so it is doing that. Okay, let it be because we have one pod running and it can handle all the traffic because we have not that much of traffic right now. So next is what we will do is we need to create a NodePool YAML and EC2 node class. Again, you can find that in this description here. I've explained these things already only. So make sure to update this with your controller role. So this is my controller role and alias as latest we are using tags. So add your cluster name over here and rest of things are pretty good. So we'll copy this and done this. So vim carpenter nodepool.yml and paste that and save this and then apply that kubectl apply -f nodepool.yaml. So NodePool and EC2NodeClass is created now. So you can view that also. kubectl get NodePool. So it's in ready as false. Let's wait to commit in ready as true section. Yeah, it is now ready. So let's check for a node class also. EC2 node class. And yes, that is also in ready. So now what we'll do is kubectl get nodes. So now you can see we have just one single node. Now let's apply some deployments. Kubectl get create deploy nginx app on iPhone image is nginx. So once we create this, the pod will not come in running state. EC2 instance will run, but that EC2 instance will not be able to join our EKS cluster because I already told that this EKS cluster should have an access entry of that node IAM role. And you can see that we don't have that Kubernetes. We have node group role, but we don't have that Karpenter node role here. So let me first apply that and show the errors, and then we'll add that role and see. So add that kubectl get pods ctl, it's in pending state. Kubectl get nodes. Let's wait for that. Now if you come here and do kubectl get nodes, you can see that only one node is running and the other node is not yet running. But once if you go to your console, here you can see that one node is already in running state of C6 large. This EC2 instance is already in running state, but this EC2 instance is not joined our cluster because we don't have that role. Now let's add that role and see how it will behave. So create a role. Uh, Name of that is node carpenter node role. This one we'll keep this as a EC2. Next, we need to choose that as EC2 Linux. And next, okay, everything is correct. Next, and then create. Come here, access. So Carpenter role is now added as system node. And next, let's see in here. kubectl get nodes. See, immediately that node came here and it is not yet in ready state. Let's wait that until it get in ready status. Kubectl get nodes. See, now it is in ready status. And if you check the pods, pod is also in running state. So now let's increase the load and see how it behaves. So we have just one single pod, right? So let's increase the number of pods here. Kubectl edit, and here we will change the number of replicas to 5. Pods, 5 pods in running state. Okay, let's increase it a bit more. Edit replicas as 50. Nodes, creating pending, some are in creating, some are in pending state. Nodes, just a second, it will launch a new node now. See, it has launched a new node. Let's see which node it has launched. Just refresh this. Again, C6 A large node is launched. And now you may have that doubt why it is just launching the C6 A large node only. And for that, let's see that our node poll. Here we have mentioned to run AMD 64, okay, category to use CMR only. So it is launching those nodes only. Generation greater than 1. So that is the reason why it is launching that C6A large. And now let's see, everyone is in running state. Kubectl get nodes. We have 3 nodes running. Let's scale down and see now. Kubectl edit. Let's make a replica as 2. So see, it has successfully started that pod to delete. You can view that in here also. See, it has terminated one node and now it will terminate this also. No, it will not terminate this because we need one pod to run that, because we have some nodes, some pods running. Yeah, we have two pods running. Kubectl will get nodes. Yeah, one node will be able to will run these two pods, and this is belongs to that system nodes to run only system related workload, and this will run application related workload. Okay guys, now we have seen the complete end-to-end demo on this Carpenter. Now let's delete our complete infrastructure. So Carpenter destroy. So type yes. So it will take nearly 15 minutes to delete your infrastructure. All right, guys, that brings us to the end of this session on Carpenter in AWS EKS. Today, we looked at the limitations of Cluster Autoscaler and how Carpenter solves those problems, and why it's becoming a preferred choice for the modern production grade Kubernetes cluster. We also deep dive into the Carpenter architecture, understanding the core components like NodePool and EC2NodeClass, and finally, we looked into the hands on demo. And if you found this video helpful, make sure to give a like to this video and subscribe to my channel, because it really helps to grow this channel. And all the required resources, GitHub link, and documentations will be provided in the description. So do check that out. And thanks for watching this video, and we will meet in some other video. Till then, bye bye.